Good morning, welcome, and thanks for coming to this talk. It's always impressive in the morning after the Unity party that anyone actually gets to any talks, and that historically that hasn't always been the case. Lots of people do not make it to talks this morning, so should all be a little proud of ourselves. My talk is called Invisible Heroes, Implementing Player Input and Camera Control in Static Sky, and I am Charles. Input and camera control systems are the invisible heroes of a multi-touch, multi-character action title. They work best by letting players focus on everything other than input and camera control. And if you went to the website, you saw that as the description for this talk. And my goal over the next hour will be to convince you that it's true. The talk's divided into three sections. The first, it's a rough split, they're not equal in time, but the first one is to provide a little context, saying what is Static Sky, sort of what drove the design decisions behind our game. The final two are sort of technical implementation. They talk about sort of the multi-touch input system and the camera control, and they're technical and there's code, but even if you're not a programmer, I think that you still get something out of them. So, I want to give a little context. And starting is always tricky, providing context, so I guess I'll go back to the beginning. And for me, that's the realization, a realization that I had on the metro in Copenhagen, playing sort of well past the ends of what should have been the ends of an endless runner, and with sort of iPhone in hand. And I was completely absorbed by this game, but I was really not enjoying it. And a thought occurred to me, and that's that I had never before in my life had so little time for games and wasted so much of it. And I don't want to get into the sort of identity politics of what it means to be a gamer, but I had always considered myself to be a gamer. My first gaming system was a Atari 2600, and I played way more Pitfall and Berserk than any little kid should have. And then in the 80s, I guess it wasn't as big in Europe as in the US, but I had a Nintendo Entertainment System, and like every kid growing up in America at that time, I played constant Super Mario Brothers. Games like Contra and Bionic Commando sort of defined my childhood, and eventually I started building my own PC and was playing like Wolfenstein, which I guess sort of introduced me to the idea of designing your own levels, and Descent, Doom. Doom introduced me to the idea of designing your own levels well. Quake, which I played sort of semi-competitively before that was a thing. And the common thing, I guess, between all of these games is that like, the most recent of them is almost 20 years old now. And I haven't owned a gaming rig in a decade, and my consoles are gathering dust. And the more I thought about this and thought about the gamer I had become, the more I realized that like I became angry at that. And it wasn't an issue of quantity exactly, because I had made decisions. I had a family, I had a career, I had these other things that were taking my time. It wasn't the quantity of time I could spend gaming; it was the quality of time that I was spending gaming. And that sort of these games, they weren't being what I needed them to be, but they were there where I needed them to be. And they were there when I needed them to be, these games that I was playing. And I was a little bit angry at the developers who were building them, but I was mostly angry at myself for wasting my own time and my own money at it, because gaming had given me so much enjoyment. And I felt like I was sort of betraying that childhood me in a way. My gameplay was happening in sort of these stolen moments and various, wherever I could get it in, and was happening sort of, maybe I would have 30 minutes, but maybe it would be 30 seconds. And there's this desire to have games that you'll get deep satisfaction out of, balancing that against the needs for something that you can have just sort of immediately there and walk away from. That's actually quite a challenge. And I was angry about that for the next few months and had sort of these ideas spinning around. And then my friend Nicholas and I decided to actually make a game. And a few months later, we were joined by a pretty talented artist and designer, Soren, and the three of us have been working on that game. So I'm going to show a short video about it, and I'm going to then talk about how these ideas sort of shaped its design. This isn't intended to be a post-mortem, but I want to contextualize these ideas before sort of digging in on input. So I hope this starts the video. Contextualizing this, what is the game? Well, you play as a remote operator for a squad of agents, cyberpunk-themed world. It's a real-time tactical action game. It's being developed for iOS and sort of embracing being mobile. And I think that last point, it goes a long way towards the sort of having a game where and when you need a game. But really embracing, like, the what that I want out of a game is sort of the heart of those formative games from my childhood. But that when and where, this sort of embracing mobile requires more than just the system, more than just thinking about the hardware and the platform, but the context that play is happening. Whether it's fundamentally different playing a game, on a bus or while your boss isn't looking, relative to playing one sitting on your couch, staring at a TV. And it's also that I think that mobile changes the relationship that you have, that touching a screen, holding a device necessarily makes that relationship different than when there's that extra distance between you and what you're playing. And so, how do we embrace being mobile? Well, we always try to stay excessively respectful of the player's time. And that first point, actually, it turns out happens, it's kind of automatic, that games that are sort of disrespecting a player's time, that are taking it for granted, that are wasting it, that tends to be the result of conscious design decisions that have been made sort of against the player. We also try to tighten the game loop, try to make it so that there's a much faster action resolution cycle than we would get potentially on a desktop or in a console. Try to help players get in and out of that loop as quickly as possible, because when you have potentially just 30 seconds, getting in matters, and because if you're going to be disrupted, being able to get out and not lose what you're doing, not be penalized for things that you can't control, becomes incredibly important. And yeah, that's minimizing these sort of consequences of interruption. And then we try to decouple the skill and accuracy, because we want this game to be one that is driven by player skill, that requires you to be skilled. But there's a lot of, both because of the context that you can't control and just the nature of holding a device and sort of boiling this game down to its core, you end up with sort of the need to have it be that you're not playing an interface. And I think that's where the input and camera control systems have a huge impact. And sort of like as we talk through those sections and I go into how they were implemented, I think decoupling this accuracy and skill, sort of allowing for intentional imprecision becomes one of the important things. So we should dig into the player input, sort of one of the two sections on this. Our player input system is designed to be as simple as possible. You just tap stuff in order to have your character act. And so you just tap things. What could go wrong? It's pretty simple, but we should still establish what that means. So in the game, you always have at least one character selected, but you can tap to select characters, tap to move your selection between them. You can tap to attack enemies. issuing a command to any of your selected characters. You can tap to take cover. When the enemies return fire, it's a world that's full of opportunities to avoid that. And here actually, the cover itself, the blocks of cover are about the size of the tip of your finger. So precision as to where exactly you take cover. You actually do the character AI takes over which side you intend, because you're basically covering the crate with your entire finger. And you tap to interact. The world is full of interactive things, hacking terminals, buttons, doors, loot crates, these various things. And there's an aspect of that becomes very game specific in that it's you have sort of going into the character processing of AI, how we handle the reservation systems for input. But there's also just generally these it's like items that have some degree of priority over other things in the world. And every other click becomes a move command, every other tap that you make. So touching the ground tells your selected guys to go there. So since tapping stuff is sort of critical, and I guess should I actually also clarify, it's tapping in the also dragging, also that it's multi-touch, so multiple concurrent taps. But since touching stuff becomes a very critical aspect of this, I'm actually going to go into some detail on what tapping stuff means, how we address that directly. So for reference, looking at sort of the simplest approach on things, we get the touch position, which gives us a screen space vector, just raycast into the scene, and we return whatever collider we hit. So that's sort of like simplest input imaginable. There's a downside to that, specifically in the case of mobile, that array either hits or it doesn't. And if it misses, you're actually somewhat deep offset from what you missed, because you've cast into the scene and hit the ground several meters behind what you were attempting to select. You've actually issued a move command at that point to tell your character, go run up and stand next to the enemy instead of an attack the enemy, which is sort of your worst case outcome in terms of players not hating you and your game. So almost hit. Fingers are fat and pixels are small. Here's another aspect of why this. The guys in this image, that's a fifth of a second offset on a running guy. And a fifth of a second seems like a long time. It's a long time if you're moving a mouse down. But a fifth of a second on a running guy means that if you tap where the guy was at that point in time, there's zero overlap on a capsule by the time you actually make contact. And camera movement compounds this problem, because this is it's a relative motion that does this. So if your camera's moving one way and you have an enemy running the other, this fifth of a second is maybe a tenth of a second, or even less in the right angle. So the odds of missing, and it's a worst case miss, because you're actually like the worst possible outcomes happening. That really goes up. And time to react is slower on mobile, because it's a device that you're holding, and especially in our game where you've got multiple characters that you're attempting to control at the same time, and multiple enemies, and it's real time, everything that's happening. This miss matters. And so our first prototypes, we used a screen space distance line test. So it's basically creating a screen space fuzzy capsule. We're representing each character with a line towed ahead. We're getting the distance from the touch position to that line, and then we're selecting the closest line. And we have a threshold at some point. And this, especially when we were starting off, worked really well. If nothing's picked, we're doing the raycast, but there were some issues that happened with actual capsule collisions that were just sort of immediately solved. And one of those is that the intent of the player was better represented by this. And I think that part of this is because of our camera angle, that when you're going in, so like the image on the left, where we have these two characters, the overlap area, either you have some pretty deep logic and you're raycasting against all the colliders and then you're determining, well, which one was important, or you're doing you're just sort of at the mercy of whichever one was actually slightly closer to the camera at the point that you hit. And probably in this scenario you'd be fine because they're both capsules and they're curved and we're sort of dead on. But you know, our game is not 2D from the side, so that wouldn't actually happen. But when you're doing these distance to line checks, you actually get a really clean separation. And because you can change the cutoff threshold per guy or per type of object that you're clicking, you can actually have objects that are important to you cutting into objects that aren't. So you can actually balance taking cover and whether a tap meant move to that cover or a tap meant select a guy. Unfortunately, it did absolutely nothing for solving the guys moving quickly problem because we're effectively still dealing just with capsules. They're screen space capsules, but they're just capsules. So we fixed it by cranking the distance. And now everything worked beautifully well. There were no more missed-taps. It actually felt really good when the camera was moving fast. Guys were zipping across the screen, you were touching, you were always getting the guy that you wanted. But just like with expanding an invisible capsule in three-dimensional space, doing it in two-dimensional space presents problems. There become dead zones that you can no longer tap. This distance to line basically made the capsules incredibly tall. We knew it was a problem. It didn't seem that big. It had sort of fixed the other problem, so I wrote a to-do and sort of went on to other stuff, but it actually was unplayable to the point that we actually had to okay, what is the real solution for this? Like, what do we really want tapping to be? Because no more missed taps it's not a good thing here. And well, after thinking about it for a while, what we realized is that what we really needed was to stretch the hit area based on movement relative to the camera. So that as guys or as the camera were moving, we had a larger stretch space, and that when things were stationary, we ended up with some pretty tight click volumes. And we did that by testing against convex holes of object line bounding boxes that have been low-pass filtered in screen space. Which basically is this. So we take our guy, we get the colliders for where he currently is, and then we get the colliders for where he was in screen space. And then we create some screen space, some screen space convex holes around them. And these become our new hit things. And what we're actually doing is if it's a direct hit in the polygon, we're passing that through, but otherwise we're still doing our distance checks. It's a sort of a distance to polygon check for our hit. So we get all the benefits of our threshold tests, all the benefits of this vertical line system that we were using, but sort of with a line that stretches as guys move. It turned out that this was incredibly slow. But it wasn't slow for the reason we thought. My assumption was that the convex hole was taking time to make. My assumption was that maybe these matrix operations on the putting low pass things in were taking too long. It turned out that the visibility check early out that seemed like an optimization was super slow because Unity can't make assumptions about the state of the camera. So there's a series of matrices that are being recalculated each time on each test against each guy. So we ended up actually making a sort of a built-in visibility system for things to determine which guys are on screen, which things are on screen and which things aren't, and cut 80% of the overall time for this out with that. So, and suddenly this became sort of a non-issue from a performance standpoint, and all of our clicks worked and everyone was happy, and decent accuracy. I have a video actually that shows sort of debug and non-debug views of the game. So it's a clip will play through and then play through with these volumes drawn on top of it. So we've got some guys fighting on a rooftop. And when we replay, I guess the guys have volumes that these are pretty obvious, but the cover volumes, as they sort of also stretch a little bit, we have different amount of threshold weighting for low pass. So things that are mostly static and that are big and blocky, those we don't need to stretch that much. And we still want to stretch a lot because if the camera's moving like ridiculously fast, then we actually, even a crate, we want to stretch its hit volume. But if the camera is moving relatively slow and these things are relatively stationary, then it's not that important to have them hit. So that's picking and that's working. But at some point we have to turn these actual touches into commands that the player, that the characters can process. So what we do is we take an array of sort of finger objects, and they correspond, the index for this corresponds to the actual ID for the touch in Unity. And we get we do our picking logic on those based on what state it is. So if it's, if the touch is down, we determine what in the world should this be hitting. And then we take these and we sort them by age, because if you've had one finger down and you bring down another, we actually want to make sure that first one gets satisfied first for stability. And then after that, we take these and we satisfy them. And the process of satisfying a finger in our system is that we basically take one of the selected guys and he acts on it. And once all the selected guys have acted on fingers and all the fingers have had guys act on them, that loop is done. So what we found was that there wasn't enough division between the player issuing the command and the actual command. What ended up happening is that there was a bunch of logic for, you have two guys selected, one finger down and it's on cover. As we satisfy that one finger, we have to know that there's more guys to push it into, or as we, it was just messy. These combinations, there was some combinatorial blowout that just wasn't working. So we realized that we could dramatically simplify things if we create each frame a finger up until the total that we have virtual fingers and real fingers combined, that we have at least as many inputs as we have guys. So a simple example of this would be, I have two guys selected and I touch the ground. Before attempting to issue the commands to guys, we say, okay, well we need another finger because there are two guys. Let's create one that's offset slightly on the ground so that we can send request two guys to go to two positions. And this, we're ensuring that these total fingers are greater, and it lets us sort of pull these things apart and make some assumptions and have some decently clean code when it comes to assigning commands to guys. The other thing that we found was that synchronization of multi-tap events actually becomes a problem, because if you have two fingers down, you have two guys selected and two fingers down on, for example, two different enemies, and you attempt to pull both fingers off at the same time. One is usually a couple frames faster than the other. Like, even though we think we're pulling them off at the same time, we're really not. And what we end up then with is 2 frames at the very end of this ordering issue where we say we have 2 guys attack 2 guys, and then 1 finger remains down slightly longer, so now these 2 guys attack 1 guy, and it's very confusing as to what's happening. So after touch phase ended for any of these fingers, we actually keep it around sort of in a ghost state until there are no more real fingers down. And then we execute all of them at the same time. And we no longer update the screen position of it while it's in this state, but we keep the actual sort of picking code happening constantly on it. So they can time out. It's probably only lasting a couple of frames, but it makes sure that sort of concurrent multi-tap events are possible, and you can send your 2 guys each up to attack a guard at the same time, and that you don't end up with overkill on one and another guy being shot in the back. Satisfying the fingers, so the last step on that, it's actually mostly game specific. It's how do we reserve cover? How do we make sure that the guys are moving into attack range before attacking? But there's one thing about it that is actually sort of general, is that we want to preserve the relative relationships between the guys who are between your selected set of guys and the positions that they're assigning. So we want to not just send each guy to the closest touch location, but we want to send the guys to the closest touch location that also keeps them relatively positioned together. And we do that so we get the middle of the character positions of all of our selected guys, and we get the middle of where our fingers have gone down in world space, and then we project the characters onto that and then we solve for distance. And by doing this, we end up with guys on one side stay on one side unless there's such a dramatic difference in rearrangement that closer still means closer, in which case that feels pretty natural for them to cross over anyway. So that's sort of the whole input loop, sort of from fingers going down to commands being issued, handling touching, and this sort of goes then into our camera control setup. Because these two systems are pretty deeply linked, because we're trying to keep both to be incredibly simple, incredibly straightforward, and you can't have a simple input system if you have a complex camera system, because we actually need to make sure that like we would have to, if we allowed the player to do panning the camera around, we would have to have a separate sort of contextual type of input that lets them do, that lets a pan command be issued. So to keep one simple, we need the other to be simple as well. So we make sure that it's simple. So where do we do that? No direct player control. We have a pretty fixed camera angle, so that works to our advantage in this, and we have a relatively low field of view. That also, these things actually help a lot. Sort of this pseudo-isometric really gives us a pretty decent advantage when it comes to making camera simple. But the camera zooms and pans to frame the relevant stuff. And for example, we have an enemy sort of approaching a guy. As we run away from him, the camera pans back to keep some distance. As we move in, as we stop and the enemy becomes closer, we can zoom back in. So it's a pretty simple system of keeping things framed. But we need to know what the relevant stuff to keep framed is. So we start with the idea of a selection set. And these are the various combinations of guys we could have selected, characters we could have selected, and we just determine which set. So if you've got two characters, it's the combined set and then an individual set for each. It's a way for us to, it's more of an optimization thing than anything else, because it means that we can actually be testing and caching some of this stuff and not doing it every frame. The actual selected characters are automatically included in this sort of what's relevant, because you need to be able to see your own guys if they're selected. We also take the offset points based on the velocity of the characters. This gives us a little bit of look ahead. As you run, it pushes a point forward. That point is important as well. Points triggered by timelines and scripts are important. If a designer has decided that a cinematic view over part of the city is important, then that needs to be included. If something for, a hint to head down an alley is important that got triggered by a timeline, that point is important as well. Also, positions of any enemy that you're actively engaged with. If someone is attacking you, or if you're attacking someone, that enemy is important. We need to make sure that you can tap that enemy, that you see that enemy. All of these things are definitely relevant for the system. The interesting thing is the things that might be relevant, the things that you're not actively engaged with at that moment. So these potentially relevant things. So let's start by what things might be potentially relevant. Well, enemies that the player can see. If you can see an enemy, that might be relevant to your guy. You might want to tap him. Whether you have a line of sight or not. We're sort of you're the remote operator, you have the view on things. If you can see an enemy, you might tap the enemy. Enemies the character can see, but you can't. This sort of avoids surprise. Just because the guy's not on camera, if your character can see him, then the AI can probably also see your character. We probably want this to be something or it's potentially something that we want to be able to touch. Enemies that somehow otherwise know about our character, and maybe it's scripted, maybe you set off an alarm and they're responding to that. Maybe you actually, maybe they heard a gunshot, or they're off screen, there's not line of sight, but they know you're there. They've notified the player, I know about you. They might be interesting as well. So for all of these things, we don't want to automatically frame them, and there's sort of a creative reason and a very technical reason for why we don't want to automatically frame creatively. Emphasis is one of our, emphasis can be given by what we frame. It's a powerful tool for telling the character what's important. And if we're overdoing this, then we're basically telling them everything's important all the time. And so creatively, we actually want to have some control over framing there. But technically, we end up with a problem if we automatically frame anything that's potentially important, in that once that happens, once an enemy's on screen, there's no way to run away from them. There's no way to get them off screen, because we're constantly saying, yeah, that's important, let's keep it on screen. And so you end up just with a camera that's constantly really far back, because anything that ever became important stayed important. So what we want is a point somewhere between your current selection set and this enemy, based on how relevant the enemy is. And that's the point that we actually keep. So as an enemy becomes less relevant, it gets less pull, and as an enemy becomes more relevant, it has more pull. So how potentially relevant is an enemy? That's tricky, but we already have that information to access. Our AI is using an influence map system to determine, like old school RTS style, to determine sort of some tactical knowledge about the battlefield. It's, let me play this. It's using this to take paths through an area that might avoid conflict. It's using it to determine which way to retreat or which way to press an attack, whether it's in isolation or whether it's in a powerful position with its friends. So we already have this information, because an influence map is effectively saying, at this position, how important, how relevant is it? And we can actually use this sort of composite influence map that was shown. It's PC versus NPC, but we also have a really clean PC influence map, which is effectively just the PC's position that's being diffused in the world and then having some degree of decay. So as we move back and forth, we can see that like where we were, that's pretty important, but also an area that sort of expands out, that becomes important as well. And if we query then at a point where the enemy is, and sample the player's influence on that point, it's not a linear response, but that actually gives us a really good way to determine how relevant this enemy might be. And it's nice because it wraps around corners. It behaves in a somewhat natural way. You don't get jumped through walls or across gaping spaces between buildings. Things that would actually break the relevance of the enemy potentially for real. And it gives us sort of this ability, like a clean, simple way to sample and say, like, how relevant is this guy here? He's 0.2, and so we look up and say, that means we walk half the distance out to him, or whatever the case may be. And sort of we build. So as they pass out of influence, then we're actually able to pull that number back, because the 0.2 becomes 0.1, and so we start pulling this value back. And here actually we have an enemy that's sort of passing through the edge of influence, and we can see sort of the relevant points being contained inside this disk, pulling back towards the character. The disk is the disk that you were seeing there is actually what we build from this. So we take these points and we create a disk that occludes all of them. We use that disk then to determine both the position that our camera should be aimed at and the distance back we need to dolly it based on the radius of the disk. So it's what we end up framing. And so for this, we take sort of the projected into the scene distance to the center of the selection, and the square rad, the radius that we're looking at here, it's the maximum radius squared of one of our points to that center. And from that, from the center of this disk projected back into the world, we end up with a point that we focus on. And then we're able to actually do sort of some based on what our field of view is, and I guess we have some clamped values. We end up with a distance that's sort of in meters how far back our camera needs to be to keep that framed. There's some other details with the camera that I sort of want to go into, and those are that they're more game specific, or at the very least sort of polish polish focused. One is that our use of field of view, we go into hack mode in our game. I mean, it's a cyberpunk game, you go into hacking. So what we actually do here is we collapse our field of view and go into sort of an isometric mode. And we, I can show, actually, it's probably easier to see. What we do is when we go into hacking, in order to maintain a relationship between the things that are on the screen and the things that you're rewiring to hack, we project it back and then try to get it so that a meter at our focal distance is a fixed pixel size so that we can overlay sort of a projected grid on top of it. And it's super game specific, but it gives us some interesting things that we can do afterwards. So for example, if we go into sort of a bullet time mode, or even if there's an impact, we can sort of tweak our field of view and keep focus on it. And it's one of those things that becomes relatively easy to do in the overall system. Other implementation details that are also, so we interpolate camera positions. That wasn't in the sort of code that was shown, but like it makes sense to have that be smooth. We clamp our min and max values. Otherwise, if there's no enemies around and you're not moving, your disk is the size of your guy, which means you're zoomed way in and don't see what's happening. So we have some min-max values on that. Based on the difference between your selected set of guys and the overall set of guys, we actually take that vector and use it to do a little bit of camera rotation. It's just a few degrees. It gives a little bit of an extra look ahead, makes the camera feel a little bit more dynamic. While you're playing, you don't really notice. While you're watching someone else play, you definitely notice. It's one of those kind of things. These kind of things, I guess, with the way that the setup is, become really easy to experiment with and see, does this work? Because you have this constant reframing of your camera saying, okay, well, if this point is that way from there, how does this feel? It's really easy to get some sort of test iterations on various levels of types of polish, I guess. We pad the screen because if you're actually zoomed out on things, these points that on the disk, we actually don't want them pushing the edges exactly. We want a little bit of a border around. Especially on the side where we have sort of these fixed GUI elements. On all the screenshots you've seen, sort of, it's a fast select bar for the characters that you have. We don't want if by definition the things that we're framing inside this disk are things that we're saying are important, we don't want important things under our GUI. So we offset the entire framed thing. So we're framing it inside of a rectangle smaller than our actual screen. We have another thing that's sort of hard selection versus soft selection. If you've jumped to a guy who's off screen, we don't want to do really large interpolation. We want you to get there right away so that you're able to do things. But if you're tapping another guy, it's easier to who's already on screen. That selection change should actually give you, you want to be able to see sort of that distance, like where you went, sort of keep context on things. So sometimes we sort of reset values and give you new ones entirely instead of interpolating between them. So yeah, it's pretty fast sort of implementing these things as a result of that. Yeah, so that sort of goes through the camera setup on things. We've got the overall goal between input and camera being to keep things simple, to keep things to allow the player to focus on the other elements of the game and keep things working. So I can actually, if anyone has any questions, any questions at all?
How many characters?
There's our camera. Yeah, not a camera.
Thanks a lot. Very interesting.
Thanks.
How many characters are in your squad in total at the max?
Simultaneous. So we have most mission. It depends on the mission. Most missions have 2. There are some solo missions. Some have 3. Pushing beyond 3 we found was a problem, especially on. I mean, you can play it on a phone. That's a really small touch area on an iPhone. And a lot of times the balance makes it so that you might have a guy who, like, there are different classes. So you could have a heavy weapons guy that you can put into Overwatch and sort of have some of your active focus be on a different class. Or maybe you have a scientist accompanying you who's going to be patching you into a hacking outlet. So there's a little bit of passive time with one letting you focus on the other. But potentially you've got 3 guys who you're attempting to juggle in real time. We actually balance that a little bit. We have the ability to go into sort of bullet time slow motion, which is both sort of cool and fun, but serves a tactical purpose. You become sort of pseudo turn-based as time stretches down, so you're actually able to balance some of the issuing of commands between guys by slowing down time.
Thanks. Can't wait to try it.
Thanks.
Hello. At the beginning of your talk, you talked about being frustrated that it's difficult to find a game that is fun to play for 30 seconds a minute.
Yeah.
And I can really relate to that, and I think a lot of us can. How did you try to tackle that?
The shortened sort of loop time.
Yeah.
So there's a couple things. We're saving constantly in the game. We're encouraging you to sort of enter a room and try. And if you fail in this short time, you lose 5 seconds from before combat started. So by being able to have sort of consequence-free 30-second play, where if you have to abandon your assault, that's sort of one aspect. The other is that because we're on sort of a larger level, ramping through the story missions, ramping difficulty pretty strong. These 3 guys that you potentially have on a single mission don't represent your entire squad. So if you have sort of on a larger story mission some guys deployed, potentially you could send someone else to go, do the quick, fun, easy grind, earn some things. You didn't have time to commit to the story, but the few minutes you had was time well spent, and still progress things forward.
Cool. And it's iOS only?
It's iOS to begin with. We actually we want to. So mobile touch only at this point. We're like not thinking beyond that, and we're very much. We're really attempting to push the device to its limits, and so before we even sort of consider other hardware to support, we want to make sure that we're making the best game possible on the device that we're able to focus on. In all likelihood, we'll look at some Android vendors. We'll look at even potentially Steam down the line, whatever we can make it work on. But right now, we're trying not to get ahead of ourselves on that. It sometimes is difficult because you look at things and there's a little bit of potentially a gamble. It's a premium core game on iOS. Like there is a little bit of the gamble in that, like that it's sadly relatively unproven as to whether you can be successful with this. So you start looking at other things and a little bit of hedging your bet, but we try not to.
Okay, good luck. I hope it works.
Thanks.
Hey there. Well, I was thinking about the display resolutions that, well, you mentioned moving in the camera in and out and zooming and whatever. So how do you manage different display, not only resolutions, but sizes? Thinking about the iPhone 6 Plus versus iPhone 4S, for instance.
Right. So I think ratios becomes potentially the bigger issue. So if you're looking at the 16:9 on a phone versus an iPad, like you're framing. I don't know if you saw we were actually getting a horizontal versus a vertical. We actually have to look at the device and change some of the things, because on a phone, like just taking an iPad build onto the phone, we actually find that not only is everything smaller because the screen is smaller, but the ratio forces things back further because of vertical height, so it's sort of compounded and doubly bad in a way. And we actually don't fully have a great solution for that. we'll arrive at one. We're actually, so we say iOS, the bulk of our focus has been tablet. It was actually somewhat by chance that we did a build on an iPhone and we're like, holy crap, it's playable, for some definition of playable. So it's like the realization that we could even make a phone game sort of came afterwards, and there's still some things that need to be worked out.
Hi, thank you. I was wondering, you say that you try to keep all your characters on screen. What happens if you send your characters in different directions, or perhaps can you enter the room only with one character and leave the other waiting outside and stuff like that?
So your selected set of characters gets kept on screen, but you can switch between, so in the case where you send one guy into a room and the other guy you send someplace else, simultaneous selection for them doesn't work. You can, the buttons on the left are sort of fast switch buttons between guys, so if your guy's not on screen and tappable, you can choose them. And we have scenarios where you do have to send one guy to hack a terminal to open a door that the other guy goes through, or whatever the case. So yeah, you can fast switch between guys in different places. And in that case, we actually, because we have different selection sets, we have different values that get framed with each, and because we're switching to a set that the guy was off screen for, we do the hard snap instead of interpolation. We actually take the position, it's not just a hard snap, we're taking a slightly offset position from it, so we get a little bit of a motion to hint where in the world you came from, but we don't have this giant interpolation across half the level to get to where your guy is. Yeah, well.
Hi, thank you. This is maybe a silly question, but how are you handling the distinction between what is an enemy, a crate, or something? Are you layering the objects in different?
Yeah, so is the question, how technical is the question supposed to be? So we have this idea of a tap target. And a tap target ties into our visibility system and it ties into our input system. And when we actually, it is what is creating these low-passed volumes. And it has a direct reference to an object that we can then query and say, like, what type of thing did we click? So we do use layers for the impact, but that's from a calling standpoint, not from a which thing did I hit standpoint. The tap target has the pointer to what it is, and then we just determine what type of thing it was. Any other questions? I don't see anyone. So I'll actually be at the speaker area for 10 minutes, 15 minutes or so. So if anyone has any questions there or wants to do anything, you can come see me. And thank you all for getting up this morning after the party and for actually attending. And I guess it's about lunchtime too, so that hopefully there's some energy this afternoon. So thank you all.